questions you guys have? So don't now. There's this thing called a hypothesis, but a theory actually takes into account a bunch of observations that you do, and hopefully you have a bunch of observation or data that you can collect. You guys remember collecting the data for the temperature when we heated something up and the pressure changed, and that had that on that little table, and you graphed it? Okay, so you were actually taking data and looking at it, and you were coming up with a theory and said, well, as the temperature goes up, the pressure goes up. And the reason for that is the molecules are moving faster because temperature increases their average kinetic energy. Average kinetic energy has to do with their speed. Okay, it's just a different way of saying the speed. So a scientific theory just helps explain a behavior. Okay? And you're doing it the best you can with as much information that you have out there. So I'll go ahead and have you write that down. It's just one sentence long. It's a statement. It can be a series of statements. That's why I have that S in there. That explain a behavior observed in the natural world. So science looks at the natural world, looks at nature, and how it acts, and how it changes due to manipulation. So we do a lot of manipulation. We change some variables. We decrease the volume. We increase the heat on something. We add more of the gas to something. We take gas molecules out of our bell jar. You guys remember? We took gas molecules out of that yesterday, and what happened to the balloon? Went up. The question is, why did it go up? And so we try to explain that. We've got to come up with a theory of explaining that. So that's what, when we talk about scientific theory, that's what it is. Any questions you guys have? You've seen this a lot of times, especially when you start in a science class. They'll go through the scientific method and they'll say, you got this hypothesis, and then you want to test it. And then you're going to make some of these observations. And if you have to go back and do some retesting and change some things, you do. And eventually you come up with a theory of why something behaves the way it does. And that's really all part of it. Now, what you're going to see today is this thing called the scientific model. And it coincides with a theory. So a model is you set up something that can be used to represent that theory and explain it. So, for example, like you turn on the weather and you listen to the weather guy, and they have these models. Like, in a week, we're going to get this huge snowstorm. Okay, we think.
I thought that was on Friday.
See, you're already watching it. So,
We're supposed to get a huge snowstorm?
no, they're supposed to get colder and some. But
School getting canceled.
a meteorologist, they have a bunch of data and information from all these models that are generated through taking a look at the atmosphere and what it's doing out to the west of Nebraska, or to the north, or to the south. And eventually that system will either come in and it will go down below us, go up above us, or maybe hit through our area. The middle of Nebraska has been really hit, and North Dakota and South Dakota with a lot of snow, and that we don't have any.
Thank you guys.
Okay? So, everything's model generated, and guess what their models do over time? They change. As the closer they get to the time in which event's supposed to happen, those models tend to change. They shift. And so all a model is to do is it explains what's going to happen, helps explain what could happen in the future. Okay? Or what's presently happening. Okay? That's what a model is. Now, you guys have already written a definition here, but these are 4 things that models will do. Models are developed by making observations. So you're going to, by making an observation, you can create a model. Models can change over time. Models can be used to make predictions. We talk about the weather. Models can help develop new ideas. So that's just a few things about a model and what it can do. Now I'm going to show you a model here in a second that you guys are going to use on tomorrow. Okay, when you're done with it, you're done with it. Okay, and as long as you don't cause problems for the sub that comes in, it'll be an internal sub, it'll be a teacher that'll come in. But once you're done, I'm just going to give the script, tell them once you're done and show them that you filled out everything the way you were supposed to, then you're free to work on different things. All right? So I'm going to show you this model here in a second once you guys have written those down. So models are developed by making some observations. Models can change over time. As you get more and more information that comes in, it can support your model or it can not support your model in certain areas. This is a whole part of engineering. Engineering is a part that's science and math. A lot of math, a lot of science associated with it. They use models all the time. Okay? They simulate models all the time. Engineers simulate models so that when they've got this expensive equipment that they're going to try to do something with, they've already run through the scenarios. Okay? So that they're pretty foolproof that if we do this, it's not going to break this $1,000 or $100,000 piece of equipment. Okay, like when they shoot off a rocket to send a satellite, they don't want to have a mistake made to where it blows up or it goes off in a certain direction and it causes it not to go where it's supposed to. Okay, and so
those are more than $100,000.
They are, yeah, they're millions of dollars. Okay, so they run simulations all the time. All right. A lot of times these are mathematical models in theory. So, I'm going to go ahead and show you this site. And this site...
Is it a gizmo?
No.
Good.
But I think you've worked with these before.
Oh, you showed us one last semester.
Now this is a little different than that. It has a lot of similarities to what I showed you, but it's a little bit. Now, this is a model. All it is a model. Okay? And so what you're going to do, this adds heat. This cools it down. This allows you to decrease the volume. This causes you to increase the volume.
Yikes.
The temperature will show here when you add heat, cool down. If you want to add particles, this is how you do it. This is the easiest way to do it. You can use the pump too if you want to do that. Okay. If you want to load light particles, you can do that. Okay. If you notice, the temperature is around 300. What you'll do tomorrow is you'll keep the volume constant, which means this cannot get any bigger or smaller. So if I add more molecules, what happens to the pressure? What happened to it?
Increase.
Yep. Okay? And so let's say I want to keep the temperature constant. If I add more molecules, what happens to the volume? Yeah, it's going to get bigger. Okay? Or the pressure is going to get bigger. So some of these you got to keep and remain constant. You can't change them. So these are models. Is all this is. It's modeling. Okay. So we're going to finish this up real quick. So we have this thing that we're going to talk about. And most of these, you guys will. These statements are easy to understand. So this is what's called the kinetic, meaning in motion. Molecules in motion of gases. That's all it is, called kinetic molecular theory. So it's molecules in motion. And we're going to give 4 statements that are part of this theory. For each statement, we'll take a look at that little example, or I got a physical example I'm going to show you too. Okay, so all gases that are called an ideal gas has to fit under these 4 statements. Now, not all gases are ideal. What I mean, not all gases will follow the behavior of these 4 statements perfectly. Okay? They won't okay, follow these statements. So, if you hear this word ideal, that means the perfect scenario. Okay? An ideal day. What would an ideal day would be for you guys? What would be one part of your ideal day?
Skipping 6 hours.
Skipping 6 hours. Okay?
Not coming to school.
Well, yeah, that works.
Not coming to school. That's your ideal day. What would you do?
Go on a road trip.
Go on road
My
trip.
Sleep.
ideal
Some of you sleep in.
Fishing,
No, I
then
wake up
working,
early, man.
Fishing.
and then fishing again.
Fishing, working, and fishing.
Yeah, because I gotta
Earning
make money to go fishing.
Okay. You like ice fishing?
Oh yeah. It's not cold enough here yet.
No. Not
Yeah.
yet. If you're up north, it would be.
It's not warm enough to go regular fishing, but it's not cold enough.
Well, each of you have an ideal day that if you were given the possibility of tomorrow being the ideal day, you would have certain things that you would choose to do or not do that would be part of that ideal day. Well, gases have to follow this behavior to be considered an ideal gas. Okay? So ideal gas, that means all gases need to follow these statements. They're tiny. The smaller they are, and the greater distances that exist between them, that is a good ideal gas. So the bigger the distances between particles, and the smaller the particles are, the better the gas it is. So look at the periodic table. When you look at the periodic table, you know a little bit about the periodic table. Which element up there, we're talking about elemental gas, do you think would be most ideal? So these red ones are all your gases at room temperature. So which of those do you think would follow this characteristic? And I'm looking for tiny particles. So which ones up there do you think are the tiniest of the particles of gases?
Hydrogen.
Yeah. Hydrogen would be most ideal because it's the tiniest particle according to this statement. Which one of these, now look up there, which of those would be least ideal?
Lorraine, or what LR is.
It has to be the red ones.
Orange.
Which one?
Nitrogen.
Nitrogen? There's some that are going to be less ideal than that.
RN.
Yeah. Because when you go down the periodic table, you get more protons and neutrons, and it gets bigger.
Little.
So radon,
Oh, we were looking at that bottom equation. For what?
well,
How do you know?
Xenon.
because it has more protons and neutrons, and it's just it'll be a bigger atom because of that. Does that make sense?
Yeah.
So radon would be the worst
Yeah.
ideal because it's bigger. Okay, so I want to go back to this little video real quick, and you guys tell me which particle there, the red or blue, would be more ideal. The red one. Okay, because all we have to do is take out all the heavy ones. Okay? There's big distances between those. Versus if we take these out,
Why are they moving so much faster?
we take them out and put these in, they're a little bit bigger, and so the spaces between them will be lesser than that. Okay? Alright, so that's a model that kind of explains that statement. a little bit. Okay. Questions you guys have? That's easy to remember, right? Not too tough? Okay. There's only 3 more. They're always moving, and they're random. So gas particles set us different than solid and liquid, because gas particles are always moving,
Yeah.
and they're in constant motion. Okay? The gas particles are in constant. So the faster they move, the more random they'll be. So the faster they move, the more random they'll be, and so that's a good guess when we take a look at it. So let's go back, look at our okay. So you guys see how we can't predict where these are going because that they tend to move in all different directions. Does that make sense? So they're moving in all different directions. If we heat them up, they're more random.
Try keeping your eye on one single dot.
I'm not going to do that.
When I hit another dot, then they go a whole different direction.
Hey, where'd that one go? Oh, there it is. Nope, nope. Okay? So, they're more random. And
I'm so many particles. A lot.
well, you guys get to do this tomorrow. I don't want to take your fun away
No, I'll do it.
because you're going to do this tomorrow. You'll have so much fun doing this yourself.
I
I
know
won't
you
get anything else
will.
done.
Add a lot of.
I can't take that fun away from you.
No, it's fine.
Okay?
So I'll probably be sleeping tomorrow or something.
Okay. So, when gas particles collide, they're called elastic collision. When you get in a car accident, most of the car accident is not an elastic collision.
Yeah, it just hurts.
Well, the car will slow down, or if not stop. Elastic collision is where you have like bumper cars. They hit, bounce off one another. That's my favorite ride when I go to the amusement park. Bumper cars. Bumper cars?
Oh, you get whiplash.
No, they got the straps. You know. Okay. So
The ones at Worlds of Fun are fun.
Last time they were so busy, I didn't get to ride them.
Really?
yeah. So and it's terrible to do bumper cars if you get a bad one. That's slow.
Oh, yeah, because everyone else just waits for you to get out.
Or it doesn't turn away, or you get stuck, like 3 of you get stuck together and you're trying to move it to get out. Okay? So,
Dude, we get whiplash from those.
you tell me if this is elastic or not.
No. Yeah,
No.
it bounced. Why is it?
What do you got in there, sand?
Okay? So tell me if it's elastic or not.
Yeah.
Yeah,
That's solid rubber. That's got sand in it.
No, this does not have any sand in it. It's a different polymer or
It's
plastic.
just plastic. It's a harder plastic.
Well, it's still bounced.
Well, I'll head it around as long as you guys don't get too carried away. So this one, I used to show it like this, if I hit them down, okay? That's what they do.
What's in it?
Even this is going to lose energy over time. Okay, eventually it's going to come to a stop. They're
As
saying
hard as you can with it.
they're saying that gases are perfectly elastic. Okay, or really, really close to perfect. They don't lose their energy compared to other things that are bigger. And that's the last one I'll have you write down. So this is the last one I'll have you write down.
Elastic energy.
The faster the particles move, the greater their kinetic energy. So then I got a statement down below. It says all gases at the same temperature will have the same average kinetic energy. Okay? All gases at the same temperature will have the same kinetic energy. Okay, guys, we'll just review these super quick. I'm going to give you out a sheet. I'm not going to give it out today, because if I give it out today, you guys will... I'll need to take a look at you guys' notes.
I didn't write very much.
Yeah, I know.
It's okay.
That's fine. Do what you need to do. So, these are really easy statements. If I have you rewrite them out in your own words, they're really easy. And we'll review them from time to time.
Two things.
Keep your notes out. I'll come around and check them all. Okay. So, a theory explains behavior of gases. Okay? So, when we're looking at this theory, right? This is really simple. Gases are tiny. There's big spaces in between them. That's why you can compress them. Does that make sense? That's why you can take a gas, okay? That's why you can take this gas and compress it. It explains why gases you can compress, but liquids and solids you cannot compress. You cannot compress solids and liquids to make smaller volume.
Because our particles aren't moving fast enough?
Because their particles are too close to one another. That's why. Okay? So, that explains why you can compress a gas. 2, they're in constant random motion. Okay? So that means that gases take the volume or the space up of the container that they're in. Liquids don't take up the whole space of the container that they're in, unless it's full of the liquid. Okay? Solids also. Okay? When they collide, they're perfectly elastic. That means they hold their energy. Okay? They hold their energy. And then the last one is that the faster they move, this explains temperature. As temperature rises, that means they move faster, more collisions, more energy. And that describes a little bit about temperature. Okay? All right. So I'm going to come around and check your notes out.